It's so easy, it's not fair. Put the apples with the apples and the pears with the pears. Now we know. Hello and welcome to the Kearney Math Show. Thank you all for tuning in today. On today's episode of the Kearney Math Show, we are going to be featuring mini lesson 3, combining like terms and simplifying expressions. So if you would take just a moment, this is entry number 3. Write that at the top of your mini lesson. So by the end of today, guys, our learning goal is that I want you to be able to explain to someone else how you can take a very complicated expression and go through simple steps in order to simplify it, okay? But before we get started, I want to take just a moment to review some things we've talked about. This week, we've talked about the word variable expression. And remember, we said a variable expression had numbers, variables, and operations. And we gave those numbers by themselves a certain name, and that name was a constant. A constant was a number, just to refresh, we're just kind of going through some refreshing. A constant is a number that does not change. For example, 5, negative 23, 17, so on and so forth. Any number by itself is a constant because it does not change. 5 will always equal 5. It's just by itself, it does not change. But if we did want to talk about something that changes, we could talk about the word variable. Okay? A variable is a letter or symbol that stands for a number. And variables constantly, that root word of variable, vary, it changes. So sometimes we may have X, we may have Y, we may have XY. A variable can change because sometimes X equals 3 and sometimes X may equal 23, okay? Now, if we were to put all of those together, those constants and variables and operations, we have what we talked about up here, which was a variable expression, okay? And in a variable expression, there are things called terms. A term, terms are separated by addition or subtraction signs. So if you look at this example here, A plus 2B plus 5C minus 6, we have, this is a term, this is a term, another term, another term. So we have 4 terms there. Okay, terms are separated by addition and subtraction signs. Okay, now if we have a term that, for instance, is like 2b, that number that's being multiplied by that variable, that number is called a coefficient. Can you say that word? Coefficient. Or as Ms. Kearney likes to say, coefficient. So that number that's being multiplied by the variable in that term is known as the coefficient, okay? So terms can be lots of different things. They come in different forms. For example, a term could just be simply a constant, which we said, remember, a constant is just a number by itself that does not change. So a term might be a constant. A term might be a variable, or a term can be one of the, like a combination of those. For example, a number multiplied by a variable, 3m. In that case, we said that 3 was a coefficient. Okay, so again, terms are separated by addition and subtraction signs in variable expressions. Okay, now we could take it a step further. Let's not just talk about terms. Let's actually talk about what are like terms. Okay, it's exactly what it sounds like. Like terms are similar. They're alike. And we can combine like terms to simplify expressions. One important thing to note is that all constants are like terms. Okay, we can combine 5 and 7. We can combine 2 and negative 13. So constants are like terms. They can be combined, okay? Another, if you have more than just a constant and that has a variable, then those like terms have to have identical variables with a raised power that is the same, okay? So if it has a variable, it has to be identical. Just like the video said, you'll put the apples with the apples and the pears with the pears. So that means we're going to put the x's with the x's and the y's with the y's, the xy's with the xy's, the x squareds with the x squareds. They have to be identical, okay? So here are some examples of like terms. 2a, 3a, 9a, and a. They all are like because they have that a, okay? Another example, 9x squared, 4x squared, and 18x squared. Another set of examples of like terms, 6xy, 5xy, 12xy, and xy. Okay? Those variables have to be identical. Now what I want you to do is I want you to be able to take these numbers right here, and I want you to separate them out into their like terms. So you're going to put the x terms here, the y terms, the constants, and the b terms. Okay, so take just a moment, pause your video, and separate those out into their like term columns. Okay, so go ahead and pause the video. All right, so let's see if you got it right. So for my x terms, I have 3x, 5x, 4x, and I missed x. Okay, my y terms, I have 9y, 6y, and y. For my constants, remember constants are just numbers by themselves. I have 6, 3, and 5, and 7. And then for my b terms, I have 4b, 10b, and 2b. Okay, and if you see any that Miss Kearney missed, then you can just plug those in on your sheet. Okay? So now that we talked about what are like terms, and yesterday we talked about the distributive property, we are going to put those together now, and we're going to actually dive in and start simplifying some expressions. I love this stuff. Okay, so what I want you to consider is I want you to consider this example down here. Okay, right here. I didn't need to circle that. My example 1. Okay, I'm going to write a little bit bigger so that we can really analyze it and simplify it. Okay, now we are asked to simplify this down as much as we can. Okay, so I know at first this looks like a really long, complicated problem, but all we're going to do is we're going to go through 3 simple steps to simplify this. Okay, the first step, which is number 1, is we're going to use distributive property when necessary. So do you see any distributive property in this problem? Yes, so we're going to distribute the 3. So 3 times, and remember, you're only distributing it to what's inside of the parentheses, not everything in the problem, just what's in parentheses. Okay, so 3 times x is 3x, and 3 times positive, remember that's a positive 3, is positive 9, so we have plus 9. And then we're just going to bring down the rest. Okay? Now, step 2. So we've done step 1. We've used the distributive property. Step 2 is we're going to identify those like terms. So we're going to go in. And what Miss Kearney likes to do is I like to use shapes to help me identify like terms. So I'm going to go in and I'm going to circle 3x. And what do you see is like 3x. You see that 2x. Now, I want to make sure that you see this very, very important thing. When you're circling like terms, you've got to make sure you include the sign in front of the term, because that tells you whether it's a positive or negative term. Okay, so that 2x, we're going to circle the plus 2. So that tells me it's positive 2. And then, I'm going to square. What do you see as like the plus 9? What can we combine with plus 9? We can combine minus 8. Okay, and now our next step is we've done step 2, we've identified, and then step 3, we're going to combine them. Okay, so 3x and positive 2x. So 3x plus 2x is 5x. And then a positive 9 and a negative 8. Are the signs the same or are they different? They're different. So same signs add, different signs subtract. So I'm going to subtract. 9 minus 8 is 1. And then if I take the sign of the bigger number, which would be 9, that would be a positive 1. So I can just write plus 1. Okay? So let me just recap. What we did was we first used the distributive property. Right up here. Next, we identified our like terms. And then finally, we combined them. Okay? So, what you can do now is if you would like, you can use those same steps. And if you go to the top of the next paper, when you see example 2, is you can use those steps to try example 2. Okay? So remember, let's go through our steps. The first step, see if you can use the distributive property. Next, identify your like terms. And then finally combine them, okay? And we're going to stop there, and you're going to try example 2, and we'll check it when you get to class. And then that way I can see what questions you have, and we'll do some more practice together, okay? So just to recap, our 3 steps again. 1, use the distributive property if you can. 2, identify those like terms. And 3, combine the like terms. And please, 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 don't forget to include the sign in front when you're combining like terms, okay? So good luck on that next example, guys, and I can't wait to hear what you've learned and if you have any more questions. All right, good luck, guys. Peace out, rainbow trout and speckled trout. Love you, mean it.